Hi, this is Sue McBride, and this PowerPoint is going to be about section 2.4 from our text statistical reasoning for everyday life, and we're going to be discussing index numbers. The learning goal is to understand the concept of an index number, so the objectives you'll use to show that understanding is to properly use the formulas given in the PowerPoint to find an index number and interpret it. And in particular, we'll look at what's called the Consumer Price Index, which you see referenced in all kinds of publications as a way to measure inflation. So remember, inflation is just prices going up. You know, you hear about, oh dear, the cost of inflation. So we're going to talk about that a little bit more today. First, what is an index number? An index number provides a nice simple way to compare measurements made at different times or places. We're going to do this by forming a ratio or a fraction of the value at one particular time as compared to the base or reference value. So to find the index number, you'll find you'll take the value you're interested in and divide it by the reference value, and then we'll multiply by 100 to get a simple percent. So a quick example of this is if, let's say my husband weighs 200 pounds and I weigh 100 pounds. I want to know how much more he weighs than I do. I'll just take 200, divide it by 100, and I'll get 2. So he weighs twice as much as I do. If I multiply it by 100, that would be 200%. So we're going to take a look at both of those things. Now, if you go to Blackboard, you'll see a content area called Formula Sheet and Tables. So you will always be able to use the formula sheet. So here are the formulas we've done so far from Chapter 2. We talked about the absolute error, change or difference, relative error, change or difference in the prior sections, and the last one is this one for this index number. So you just have to know how to use the formula. You don't have to memorize them. 75 again, it was 0.567. And I get 3.61, so when I multiply that by 100, my answer to the, think about it, for me anyway, is my index is 361.6. So the price is 361.6% higher than that 1975 price. All right, so let's make some comparisons now with our index numbers. So we're going to continue using table 2.1. This is also in your textbook. So suppose it cost me $7 to fill my tank in 1975. How much did it cost to buy the same amount of gas in 2005? So I want to find those indices. So my 2005 index says the price of gas was 407.5% of the 1975 price of 56.7 cents. So what I'm going to do is multiply that percent, my 407.4%, times my $7. So remember to move that decimal place back. So I would multiply 4.074, which I get from my price index. And remember, it's a percent, so I have to move it back too, times the $7. So this makes sense. If it was $7, it's about 4 times as much. So my price today, my price, what year did they give me? 2005, was $28.52 for the same thing that cost me $7 in 1975. So in order to use your index number, you'll take the price that it was in the 1975, because that's my reference, times that price is a percentage. So you just got to remember to move it back 2 decimal places and multiply. Pause it and go through that again if you need to understand how to get the number from the chart and why you're going to multiply it by 7 to get the price for 1995. All right, let's look at another one. Let's say it cost $20 to fill my tank in 1995. All right, so that's the more expensive one. How much did it cost to buy the same amount of gasoline in 1955? All right, so here I'm kind of going backwards. All right, so table 2.1 shows my price index, remember, is 1975, is my reference, but my 1995 index is 212.5, and the index for 1955 was 51.3. So I want to find the ratio of the index for the 1955 as compared to 1995. So when you want to do one of these comparisons, you're going to form a fraction that does the one you're interested in. I want to know the $20 to fill my tank in 1995. That's going to be your denominator. That's your reference number. So I'm going to put that one in the denominator. The one that I'm looking at to compare it to is the 1955. So the tricky part is knowing which one to put in the denominator. That's the one I always start with. So we'll do the 5.13 divided by the 112.5. So I know that it costs me 0.2414. So I'm going to multiply that by 100 to get my, well, they didn't actually want the index number. If you wanted the index number for that, you'd move the decimal place over. But they just wanted to know what would the price be. So I'd move that decimal place back again, so I might as well just not put it in to start with. So it's about a fourth, 0.2414. So I would multiply now my price of $20 times the 0.2414, so I know it's $4.83 in 1955. Think of this as a proportion. So I'm comparing the index number in 1955 to the cost, or sorry, index number of 1995 is going to equal the price for 1955 divided by my cost for 1995. These years will drive you crazy. All right, so you could set it up as a proportion as well. They just went ahead and divided and then multiplied by the 20. But I could have it as 5.13 over 21 to 12.5 equals x over 20, and then you cross multiply and solve, and you'd get the same thing. So you're looking truly at a proportion here, where you're just setting up, make sure your denominator is your 1995 for the specific, oops, going the wrong way. So baseball players truly are way above what inflation would dictate. All right, so what about other index numbers? So we got the consumer price ones. There's also other ones called the producer's price index that specifically looks at the price to produce, or what manufacturers pay for the goods they purchase, rather than the prices the consumers pay. So the consumer price index is what you, the consumer, pay. The producer price index is what the manufacturers pay. Could be different. So other indices could attempt to measure more qualitative variables. Remember, qualitative means non-numerical. So that consumer confidence index is based on a survey about attitudes. You know, are you likely to be spending or saving? So as we go into, like right now we're working on an election year. Sometimes that consumer confidence goes up and down depending on what's happening in the political scene, or what's going on a national and international basis. So different ones get created by people trying to find those comparisons. It's a way to measure. All right, so let's look at some examples from your textbook. So look on page 70. Now here I actually wrote the solutions out, how to get them below the problem. So I'm going to talk you through them, and then you can pause it and go back and take a look at it yourself. All right, so here, number 2, we're just looking at the index number. So if the computer costs in 2000 are equal to 100, that's going to be our reference number. So they can be used as the basis for, oh, I crossed off a little something, determining index numbers. And the index number for the year is 15. How do we know about, what do we know about computer costs in 2012 as compared to 2000? If you look in your book, you can see what got a little chopped off there. Sorry. All right, so just based on the definition of the index number, that means that the costs in 2012 are 15% of those in 2000. So notice that means they went down, and we know that computer prices have gone down for the same thing, so that's accurate, much lower. Alright, so 2006 index number 6. Here the average price of a gallon of gas was $2.62 in 2006. What's the price index for gas in 2006 with the 1980 price as the reference value? So if you go back and look at the table, and it tells me in the book that I need to be looking at table 2.1, so if you go flip back to that, you'll see the price of 2.62 divided by my price of 1.22, because that was the price in 1980, and then I multiply by 100, and that gives me my index. So that says the price in 2006 is 214.8% of the price in 1980. In other words, it's 200 and some percent, 214% higher. All right, what about number 8? All right, again, we're going to use the 1980 price as the reference value. The gas price index for 2005 is 189.3, which means it's 189.3% higher than that 1980 price. So what was the cost of a gallon of gas in 2005? So this time I have to work backwards. I'm going to take my $1.22 and multiply it by the 189.3, and you can get those numbers out of the table. And then, so that's my 1980 divided by my my price in 1980 times my inflation index of 189.3. Then I got to divide that by 100, because remember that 189.3 came from a decimal where we moved it over to, so this time we have to move it back. So either just move it back or divide, and you see that the price would be $2.31. And again, you can set that up as a proportion if you want to. All right, number 12. If it cost me $23.40 to fill my tank in 2000, how much would it cost to fill the same tank in 2010? Now we know it should be more because we know the price of gas has been going up. So I wrote this out in words, so you'll find your price in 2010 divided by your price in 2000 to get your index of 1.82. So now my cost in 2010 would be the price in 2000 times that amount, because that's what my index says. It says that the price in 2000 times $1.82 will give me the price in 2010. So my price would be $42.60. And I think of that kind of like a little math equation. So I know if I just multiply both sides of that top equation by the price in 2000, the equation would say price in 2010 equals price in 2000 times $1.82. And again, you can set up a proportion, but this is a way to get that index first and then multiply. All right, now we didn't see one like this other one, the housing price index. So this is kind of extending your knowledge. It explains that the realtors use an index to compare prices in major cities. So you know, if you've ever been to, say, New York City versus Amelia County, you could take the exact same house and one's going to be literally, in New York City, you could pay $1 million for the same thing that would cost you $100,000 out in Amelia. So this is how they decide, if you're moving around the country, how you would find a comparable house in another town. All right, so they give you the index here, where Denver is our 100, so that's the one we're using the base of, but it doesn't matter. What we'll do is to find the price in a different town is to find the price in your town, or you could call it town 1 and town 2, times, and just look at that ratio, index in the other town divided by the index in your town. So you just got to make sure to get those set up properly. All right, so I just did the first one on number 17. We see a house valued at $300,000 living in Denver. Find the price of a comparable house in Miami. So I just did Miami. So if I fill in the words in that formula, so I would recommend you write the formula down and fill in the words. So the other town price, so this time the Miami price, is going to be equal to the Denver price, because remember, that's the house we know. So that's your town. That's the one we know, is the Denver price times, and now make sure you get the fraction in right. I need the index of Miami divided by the index in Denver. So that would be 300,000 times 194 divided by 100, and then work out the arithmetic, and that's what you'll get. If you wanted to do the Cheyenne one, you can try that yourself. I didn't write down the whole answer, but it would be the, let's see, I want to find Cheyenne price would be equal to the Denver price times Cheyenne index divided by Denver index. I have the answer, I just didn't write it all down. So if you want to give that a try, pause it, and then I'll tell you the answer is $180,000. All right, that finishes up Chapter 2. So go ahead and work on your homework for Section 2.4 and email me with questions. Thanks so much. Bye-bye.